Hello and welcome. In today's video, we'll write a program to implement a bubble sort. Okay, so bubble sort is one of the many sorting algorithms that are available. Um, so basically, any sorting algorithm, what it does is it sorts the array in a ascending or descending manner. Okay, and bubble sort is like kind of the easiest to understand, and it's quite easy to implement. So we'll start with bubble sort. Okay, so the basic logic is you can um, compare two adjacent numbers. Okay, so for example, this is the given array. Then what we do is we first compare -2 and 45. We check if the second number is greater, and in case we check if the first number is greater, and in case the first number is greater, then we swap the numbers. Okay, so here we are checking -2 greater than 45, which is not true, so we continue the loop, and here we check whether 45 greater than 0. Okay, so that is true, and in that case we will swap the numbers. Okay, 45 0 will be swapped to 0 and 45. Then again we check here whether 45 is greater than 11, and if it's true we will swap the number again, and this continues till the end of the loop. Okay, so that's the basic working of a bubble sort. That's the first step. Okay, so but when we have done with that first step, what we get is we have the largest number at the end. Okay, so we obtain the largest number at the end of the array, but again we have in this case 4 other numbers which need to be sorted. Okay, so then we go to the next step, in which again we do the same steps. Okay, so here you can see we are comparing -2 and 0, and 0 is greater, so nothing happens over there, and here we compare 0 11, again nothing will happen, and then we go to 11 and -9. In this case this is greater than -9. Okay, so that will be swapped. So we already had our largest number at the end, and then in this case we have the second largest number in the second last position. Okay, and we do not actually need another step where we compare this 11 and 45, because already the largest number is at the end. Okay, so you don't have to actually compare it with the largest. So in step 0 we had 5, or we needed to iterate 5 times, right? Because we had 5 elements in the array, that is we had n equal to 5 elements in the array, and in step 0 we had to loop 5 times. Okay, so here we had to loop 5 times, so 5 times we had to loop in step 0, and when you go to step 1 we only have to loop for 4 times. Why? Because already the largest number is at the end of the array. Okay, so you don't have to actually compare it. So here we only do we only do the swapping 4 times, right? And then we go to step number 2. Okay, so in step number 2 again we are repeating the same procedure, but we already have our largest and second largest over here, and in that case we just need to go till element number 3 only, so we have to repeat it only 3 times. Okay, and finally in the step 3, which is actually we started from step 0, right? So we started from step 0, so we have actually 1 2 3 and 4th step. What happens in 4th step? We have to just do the loop once only, because we already have our 45 11 and 0, which are the 3 largest numbers already at the correct places. Okay, we just need to think about these 2 numbers, right? So here we have to repeat it only 2 times. Okay, so fine. That you have to keep when you are writing the code. You can do the loop 5 times here, like for example here you had done 4 times. Instead of that you can just do 3 times also, but or sorry, 5 times itself, but that does not make any sense, and it just makes the program slower. Okay, so we do not actually need to do that, right? So now I hope you have a basic idea of how bubble sort works, and now we have to think about the loops that we require. Okay, so we had this outer loop, step 0, step 1, step 2 and step 3. So that is when we had n equal to 5, we had to have a outer loop with 4 iteration. Okay, outer loop with the 4 iteration, and then within each outer loop we had to repeat these steps, right? In the first iteration we had to do it 4 times, then here we had to do it 3 times, right? Actually I wrote over here 5, but the thing is that when you reach here you don't really need to do anything more. And then so in the first one we had 5 iteration, and here 4, and then here 3, here 2, like that. Okay, so the inner loop depends on the outer loop, and it's always depending on the outer loop. Okay, so with that in mind we can actually write the code. Okay, so let's write our code now. So we'll take Ubuntu, and then let's just see the file names. So we have reached till code 9, right? So let's create a new file, code 10. So touch code 10.c. all right. Okay, so we now have the file. Let's just open it. Okay, so here we have to start writing. I'll just copy paste some of the things from the previous ones. Yeah, so maybe till entering the elements in the array, right? Okay, so let's copy paste it, and here we are actually doing a bubble sort. Okay, fine. So now we had the include stdio.h, and then we are creating a array a50, and we are not sure whether we need all this, so for the time being I'm just deleting all of that. Okay, and then sorry, we need n, right? Because we need to get the number of elements in the array. So yeah, here enter the number of elements, then we are storing that to the value n, and then we are entering the element values, right? Okay, fine. So once we have the array, what we need to do is we have to loop 2 times. Okay, as I already mentioned here, we have 2 loops. Okay, one outer loop and one inner loop. Okay, so the outer loop we had steps 0, 1, 2 and 3, right? So we will start with the outer loop. So for int I equal to 0, I less than, so when we had 5 elements, we had to repeat the loop for 4 times, right? So we'll just write n minus 1. Okay, so n equal to 5, and we have to repeat the loop only 4 times. Okay, so I less than n minus 1, and then I plus plus. Okay, so we are starting, or we have started the outer loop. Now what we need to do is we have to do the or implement the inner loop. Okay, so when I equal to 0, we are at step equal to 0. Okay, or rather instead of I can just use the variable name as step, so it's better easy to understand. So let's say instead of I, let me just give step equal to 0, and here step should be less than n minus 1, and here you have to increment step, right? Fine. Okay, so here the value of step then will change from 0, 1, 2 and 3. Okay, because we are giving only n minus 1. And at I step equal to 0, we need another variable I. Okay, and I should go from I equal to 0 to I equal to 4, right? Or rather I equal to 3. And then we have to check the adjacent elements one by one, and if the second element is first element is larger, we have to swap them. Okay, so let's try to write that as a code. So I'll just keep this for reference over here. So we'll start the inner loop for int I equal to 0. We'll start from 0 always, and the value of I, okay, here we had 4 times, then in the next one we had 3 times, like that. Okay, so it depends on the value of step. So for that we have to write I should be less than n minus step minus 1. Okay, so just think about that bit. For example, when I equal to 0, what happens? The value of the value here will be I less than n minus 0 minus 1, which is n minus 1, that is 4. Okay, assuming that n equal to 5. So here it repeats 4 times, and when the value of step becomes 1, okay, so in this case, it does not have to repeat the 4 times. So what happens? Here the step value is 1 now, so it will be 5 minus 4 minus 1. Okay, sorry, 5 minus 1 minus 1, right? So that will be 3. So here it only repeats I less than 3, so that is 0, 1 and 2. Okay, fine. So that will be our inner loop, and now what we need to do is we have to check the adjacent numbers, right? So our array was a I, so we will check if the left side element, okay, this minus 2 is greater than the adjacent element. The adjacent element will be obtained at I plus 1. Okay, and if that's the case, okay, if the left side number is greater than the right side number, what we need to do is we need to swap the numbers. Okay, so for swapping I need another variable, let's say temp. Okay, and here what I need to do is I have to store the value of the element at I, okay, equal to ai, and then I will store the get the value of I plus 1 to I. Okay, if I did not store that in a temporary variable, what will happen? This ai, okay, or the left side element will be overwritten by the right side element, and we no longer will have the number ai. Okay, so that's why we are storing it into a temporary variable, and then finally we can store this I plus 1 value with the value which we had stored in temp, which was the ai value. Okay, so I'll just explain that once again with this particular example over here. So here, okay, let's say I equal to 1. What happens here? When the value of I is equal to 1, we are at this element. Okay, we are comparing 45 and 0, right? ai will be a1, so we are checking if a1 is greater than a2. Okay, so in this case that is true, and when it is true, what we need to do, we are storing the value of ai, that is a1 to a name temporary variable. So temp will get the value of 45. Okay, and what will happen? Next step, we are storing ai equal to ai plus 1, or a1 becomes I plus 1. A2 was 0. Okay, so A1 becomes 0, and here in the last line A2 becomes temp, or equal to 45. Okay, so we have swapped it successfully, right? A1 becomes 0 and A2 becomes 45. Okay, so that's what we are doing over here, right? Okay, so once we have swapped it, then it's quite fine. So the array now should be already arranged in ascending order. Ascending order. So now we can just print the array. Okay, so for int I equal to 0, I less than n, I plus plus. Okay, and yeah, here we just print the numbers, that's sufficient. So printf percentage d comma a comma I, right? Okay, so that should print our array, and then we can give return 0 and close the main function, right? Okay, fine. So I hope we have the entire code, so let's run it and see. We'll just clear the code here, so we can just write clear, and we have the clear screen. Let's compile the code first. So gcc gcc code 10.c. okay, so we do not have any error. So a dot out Okay, so we have to enter the number of elements in array. We'll just give the same example. So 5 elements. The first element will be -2, 0, -9, 11, and 45. Okay. Okay, so we are getting something like this over here, but I think that's one simple mistake. We can, when you are printing, we can just print it in the, or we can give a new line character. Okay, that should be sufficient. Fine. Now I think the code should be better. So again we give the same one, 5, -2, 0, -9, 11, and 45. Okay, so we have our array -9, -2, 0, 11, and 45, which is sorted in ascending order. Okay, okay. So if you want, we can give it in new line, but there are other possibilities also. For example, let's just make it more clear. So we'll just add a printf over here. The sorted array is, okay, and let's give a new line character over here. And here, instead of new line, if you want, we can give a spacing. Okay, we will give a tab. Okay, so let's try that out once again. So again we go for the same numbers, 0, -9, 11, and 45. Okay, so that looks better, right? -9, -2, 0, 11, 45. But yeah, again the tutorials came over here. If you want, you can add one more printf over here with the new line character. Maybe that can solve the problem, or that will solve the problem. Okay, so this should solve that problem also, but that's up to you. I mean, if you want, you can add this and run. The only difference that's going to make is this C tutorials will come in a new line. Okay, so I hope bubble sort is clear. Just you have to think along that logic, or how things should be done. Okay, and I just wanted to show you one more thing. So even if you are repeating the steps, okay, the outer loop, step less than n minus 1, and again here also, let's say we are doing n minus 1. Okay, the inner loop also we are repeating it. Let's see if that's going to make any difference. Okay, or rather I will just clear it, or maybe it's not fine. Okay, so 5 elements again, and in order, -2, 0, -9, 11, and 45. Okay, so here again we have the sorted array as -9, -2, 0, 11, and 45. Okay, so actually it did not make any difference, and it's just that even when we have like only 5 elements and all, this won't make any difference. Okay, if you are writing I less than n minus 1 also, it's not going to make much of a difference in terms of speed. Okay, but assume that you have 1 million values and you are trying to sort that in ascending or descending order, etc. In that case and all, this will be a huge time saver. Okay, so that's why it's better, or it's the right way to this is the right way to implement the code. Okay, so with that we'll stop the video. I guess this one was a bit longer video, so we'll go for the next code in the next video. Okay, thank you.